Hey everyone. So what I want to do here is just kind of get you started on this worksheet a little bit, get your brains back on calculus. This is more optimization, and what we're really trying to do is, one, get into some problems that are maybe a little bit more involved, and two, get us good at using the calculator more efficiently. So in this first problem, we've got the open top storage bin in the shape of a rectangular prism. The base is a square. So I've got the drawing here with x and x for the base, since I know it's the same size on all sides, but the height is going to be something different, so I'm calling it h. We can make a surface area equation, and we're told a couple other things. Volume is 3,500 cubic centimeters. It says to minimize the weight of the storage bin, one must minimize the surface area. So we need a surface area equation to minimize. All right. So I've got 2 of the x squared squares, and I've got 4 of the x times h squares. So there's my surface area equation. And notice we've got x squared, but we also have h. We have x and we have h, so I'm going to want to make a substitution, and that's where the 3,500 comes in. I can set that volume equal to the volume of the box, which would be x times h. And I could solve this for h and make a substitution. So I could get h equals 3,500 over x squared and plug that in to my surface area equation. So now my surface area is going to equal 2x squared plus 4x times 3,500 over x squared. Okay. Now, here's where I want us to be more efficient. Okay. We're going to use our calculator from here. So first thing you're going to do is plug this into like a graphs page, right? We'll call it, let me write it on the side here. On your calc, we would go f1 of x on a graphs page equals, and you type in 2x squared plus, maybe if you want, you could simplify this because it's not too hard to do. You could say 4 times 3,500 over x, since you know that one of those x's is going to cancel. And then go to a calc page, and here's where we've done this a few times. We're going to solve the derivative equal to 0. So on your paper, all you really need to write is SA prime equals 0, and then x equals whatever answer or answers we get. Okay. On the calculator, though, we do solve, and then remember the ddx, oops, not dx, dx of f1 of x equals 0 for x. Okay, you don't have to write that on your paper. That's what you're doing on the calculator. And if you do that, go ahead and pause and try that. And what you should end up getting is, make sure you hit Control Enter to get the decimal, 15.1829. So 182 or 183, and that would be centimeters. Okay. Now we still have to justify this with our calculus. So we can think about our number line here. I know x couldn't be any smaller than 0. And then there's 15. I'm not going to worry about kind of the maximum for x. It looks like it would maybe, we're not going to worry about that. We know this 15 is probably going to be the spot that minimizes our surface area. So we would say surface area prime. And I know if I plug in something smaller, wait a second, I don't have the derivative on my paper. I've got to do it on the calculator. Okay, so you can go back and you can still do ddx of f1 of x and maybe just get the derivative. Okay, or we could graph the derivative. Lots of ways you could do it. I'm going to just do my shift minus again, get the ddx, or sorry, control minus. No, it's shift minus. ddx of f1 of x. You can't type in a number yet, because that'll do the derivative of a constant. It'll just give you 0 every time. So you do dd1 of f1 of x, And, oh, it gives you kind of the answer you expected, 4x minus 1400 over x squared. And now I could go ahead and replace the x there with something smaller than 15.183. Check the signs. So maybe I type in 2. 4 times 2 minus 1400 over 2 squared. And well, we see it's negative there. And then do the same. We can see it's positive, decreasing, increasing. The nice part is you don't have to show that work. You just have to understand what you're doing. And then remember, this isn't our justification. What they really want you to say is that sentence that we've been working on of there's a minimum at this x value because, and then use your first derivative justification. So think about that sentence for a second and write that down. I'm going to show it in a moment. And then after that, also use your surface area formula because we got to answer the question. Find the surface area that minimizes weight. So we have to plug in the 15 value into the surface area equation. Use the calculator again. You've got it. F1 of 15.1829. Alright, so here's what you should have down. There's a minimum at x equals 15.183 because surface area prime equals 0 and changes from negative to positive. This gives a minimum surface area of, and when you plug that in, you should have gotten 1383.131 centimeters squared. Okay, just a couple of thoughts on number 2 and 3 here. For 2, remember that volume is the area of the base times the height for a prism. And so they give us the area of the base, they give us the height. So that's kind of where you're going to set that up. Number 3 is one similar to ones we've done. Make sure your calculator is in radian mode. Again, take advantage of your calculator on these. And then for number 4, we're given an average cost function, which is made up of a cost function divided by x. Okay? And so we're told what the cost function is, so we can plug that in there, and then we're trying to minimize the average cost. Okay? So try out 1 through 4, and hopefully this was helpful. Thanks.